Hi everyone, welcome back to Math Mondays. For today's lesson, we'll be reviewing scientific notation. And to put in simple terms, what is the aim of putting a number in scientific notation? You'll be using powers of 10 to ensure that there is only one non-zero digit in front of the decimal place. In order to do this, there are two main things that I want you to remember. For large numbers, the power for the 10 will be positive. And for small numbers, and by small numbers I mean numbers which are decimals, those numbers, the power for the 10 will be negative. And again, once you start working the questions, you'll see this put into practice. So let's get straight into it. For our first example, we will consider the number 23,056, and we're supposed to put this in scientific notation. Now, the first thing we will need to do, so usually we write back our number, putting a little more space in between to give us room to move the decimal places. Since this is considered a large number, we're going to put a decimal point towards the end. We will then, because we are trying to get only one non-zero digit in front of the decimal place, we cannot move to the right because there are no numbers there. So we will have to move to the left. So we move 1, 2, 3, 4 places. So our number now is 2.3056 multiplied by 10. And here is the part that usually confuses students. You aren't sure if you should put positive 4 or negative 4. 4 coming from the fact that we had to move the decimal places 4 times. Now, as I stated from the first part of the video, because it is a large number, our power for the 10 will indeed be positive. So we have 10 to the positive 4. Now let's try one with a small number. For our second question, we will put 0.0234 in scientific notation. Now again, as I said, usually we start off by rewriting the number with a little more space in between the digits so that we can actually move the decimal places. Now, we need to move, if we want to get a non-zero digit in front of the decimal place. Of course, if we're going this way, we end up seeing no non-zero digits. So we cannot go to the left. That therefore means we must go to the right. So we move 1 place, 2 places. And then we will see that 2 is our first non-zero digit in front of the decimal place, which is indeed all we need. So we have 2.34, and remember for scientific notation, it is always multiplied by 10 to some power. Now we move to decimal places 2 times. So we need to decide, will we raise it to the power positive 2 or negative 2? As I stated at the beginning of the video, because this is considered a small number or a decimal, we will then raise the power to a negative. So we raise it to the power negative 2. For our third question, we will now work the question which is on the CXC website. Again, for the link to these questions, please check in the description. So they asked us to put 0.045 multiplied by 10 to the minus 3 in scientific notation. Now for some students, there is a shortcut or a shorter way to do this. However, I'm going to go the long route so that we can appreciate it in its fullness. The first thing we would want to do is to consider, what does this being multiplied by 10 to the minus 3 really mean? Now, when we're multiplying by a 10 or any number to the negative power, it means we will move to the left. So a negative power means move to the left. If we had a positive power, we move to the right. And what do I mean by that? 0.045, before we go to putting it in scientific notation, we will try to put the entire expression in standard form, which means get rid of that 10 to the minus 3 so that we can really see what is happening. So we're going to move 3 places to the left. We have 1 place, we have 2 place. Since there's no digit there, we will put a 0. So this was like my first place, this was my second place, and we will move it 1 more to get 3. And of course, you place a decimal place there. So the number we are really looking at is 0.000045. And by that, I mean this digit here, let's put that in yellow. This digit here in the yellow is the same as a digit here in the yellow at the bottom. It's just represented up the top using powers of 10, and on the bottom it is in standard form. So taking that into consideration, we have, we have 0.000045, and that is what we really need to put into scientific notation. So going back to the original rules, we will move 1, 2, 3, 4, 5 places. So we have 4.5 multiplied by 10, and again, because this is considered a small number or a decimal kind of number, we will put this to the negative. So it will be to the -5. And that is how we would place 0.045 multiplied by 10 to the -3 in scientific notation.